Hi, welcome to the new AWS module.
I'm Daniel Carabas. I'm a senior software engineer working at Puppet here in Timisoara.
And I'm Greg Hardy, a senior software engineer working in Belfast. Okay, today we're going to run you through the new AWS module. We're going to have several sections just to describe how the module hangs together, works, and then a demonstration at the end. So we're going to quickly run through AWS's API specifications, which differ slightly from other clouds. We're going to go through our authentication, what decisions we quickly made, types of providers, task support, an old versus new comparison with the old AWS module, and then a demonstration.
Yeah, so the AWS specifications that we use are basically found in any AWS SDK that's on GitHub. It's basically some JSON files that contain the metadata about each service, describe an operation, and for each operation, the output and input that's required is defined as a shape. However, as you can see here, some of the operations are not quite respectful of the REST principles. So like a describe instance, its verb is a post. So it's a bit difficult to map them.
So authentication, the new AWS module, we are leveraging the existing AWS Ruby SDK. Primarily, we decided to do this because the responses are actually XML underneath most of the AWS SDK. This makes it extremely difficult. There's a large amount of parsing that needs to happen. So by leveraging the Ruby SDK, which is generated from the same API docs, we can reduce the complexity and get ahead that way. Either you can do a config file for your AWS creds or environment variables.
So the types and providers that are generated from the AWS specifications must obey some premises. So we define these operations as each segment, each definition must contain a create, a delete operation, and at least one type of get or list operation. We also took advantage of retry mechanisms that are available as a definition in the specification files and any type of documentation we found to provide for our module.
So part of the advantage of the new module that is far greater than the legacy one. The legacy module had 6 handcrafted tasks. By generation now, for the new module, we have over 1,000, which greatly increases your access and ability to use the AWS resources. They run on top of Puppet Bolt, and you can see an example at the bottom, quite succinct.
So comparing the old module to the new one, we can clearly define that for the old module, although it was built specifically and manually for some AWS operations, it does not have such a great coverage as the new one. Now with the over 100 tasks, we have a big cover of functionality upon AWS. However, we use server-side validation now instead of the higher client-side validation that we used on the previous model, but we do have a fast turnaround for new releases. And here we're going to present you through the demo. Hello everyone, so we're going to start off with something simple. Right now we have here 3 files that we're going to use for the demo. First, we're going to create some VPCs. We'll just run puppet apply, and this will create us 2 demo VPCs, demo 1 and demo 2. Let's see if these were created. So here are the VPCs that we created. Now we're going to need some subnets for these. Here in the subnets file, we're going to need the VPC IDs that these subnets are going to be attached to. In order to obtain them, we're going to use a task that's called describe VPCs. And we're going to obtain the IDs from here. As you can see, this is a JSON file, so we can use JQ and we can parse the output. In the tags, we'll find the names of the VPCs. So for demo2 VPC, we have the VPC ID here. I'm gonna add it here in the file, and then we're gonna get the VPC ID for demo1. This is demo1 VPC, so right here we have the VPC ID for demo1. Now that we obtained the VPC IDs, we're gonna use them to create the subnets. So subnets, right now we have only the default ones. Then we'll use Puppet apply subnets, and this will create us the subnets for the VPCs. Let's just click a refresh here. So we have here the demo1 subnet that's attached to the demo1 VPC, and the demo2 subnet that's attached to the demo2 VPC. Now that we have the VPCs up and the subnets, we can create instances. We have here, let me just show you, we have here the instances pp file, and we'll notice that for these two instances we're going to need subnets, since one of the instances is going to be on one VPC and the other on the demo2 VPC. We're going to need the subnets for each VPC, and we're also going to need a private key. So the best thing to do right now would be to create a private key. So we're going to use a Puppet task that's going to be called, let me just clear the screen here. So it's the create key pair task, and we're going to run this to create a key pair that's called demo key. Once you do a call, you will receive in the JSON file the key fingerprint and the key material. The key material is the private key. We're going to create a temporary file where we're going to paste this format. And this is going to give us the private key nicely formatted. Obviously, you can do this with GQ and AVK or SED straight from the command line. I thought this is an easier method here in the demo. So we're going to create the demo key file. Now that we have the key, we'll still need the subnets. To obtain the subnet IDs, we can use describe subnets task, and this is going to return all the subnets that we have on our current environment. Right here we'll find the names for each subnet. So for demo1 we have a subnet ID here. Let's just grab this and add it to the file. Okay, and we'll need the other subnet also. Where is this one? The demo2 one. Here it is. I'm just going to grab it and add it to the instances file. Okay, so let's move on to EC2. On EC2, right now we don't have any running instances. We can use Puppet again to create these two instances. One of them is going to be on the first VPC, the other on the second VPC. Well, let's refresh here, and as you can see, the instances are being created with the key that we required, the demo key. So the instances are up and running, and Puppet will ensure that these instances, the subnets and VPCs, are always going to be up. Thank you.
Thanks, guys.